Hi everyone, my name is Shreyas. I'm working in HCL Technologies as a senior software engineer. Today I'm going to talk about anti-money laundering and the application of artificial intelligence in preventing the money laundering. So what is money laundering? Money laundering is a process of obtaining large amounts of money which is generated through criminal activity. So with this criminal activity, there is a threat to the nation in terms of integrity and sovereignty, because the money obtained through this criminal activity is being used for terrorist financing also. So as you all know, FATF has imposed many restrictions on Pakistan to control this terror financing. So the criminals find out many different ways in order to make appear the fraudulent transactions as genuine, and they'll make appear the dirty money that is obtained from money laundering as clean money. So here our task is to detect the fraudulent transactions and also block the accounts in which fraudulent transactions are happening. So okay. These are the agents in the mobile money transaction system. Here, client, merchant, and fraudster, three persons are there who are involved in this total mobile money transaction system. So here, the client is a normal customer of the system. Merchant is one who serves the client in several operations like cash in and cash out, and fraudster is the one who is a potential threat to the system. Volume. Okay. So these are the categories of.
Wait for 2 seconds.
Okay. Yeah, these are the categories of fraud in mobile financial services: consumer-driven fraud, agent-driven fraud, system-related fraud, and business partner-related fraud. So, in consumer-driven fraud, what happens is the fraudster will pose himself as a customer, and he will deposit fake money through an agent, and he will obtain the same money in terms of electronic cash. And phishing, the fraudsters will send fake SMS to the customers, and you might all know they will send like you have 9 lakh rupees or 1 crore rupee, you can come and collect to a particular location. So these are all the types of phishing that they do. And there is another one known as a one ring cut. So what happens is you will get a call, just after one ring the phone call will cut, and thinking that it is a missed call, you will call them back, and they will charge money for that. Even that is a fraud. And agent driven fraud, it is employees defrauding agents. Suppose an agent has 10 outlets, and he has employees. So the work of the employees is to maintain the liquidity of cash between all these 10 outlets. So they have to go from one outlet to another outlet in order to exchange the money. So some of the times what happens is when there is lack of trust on the employees, they will take this money and they will run away. So this is also a type of fraud. And system related fraud, password or pin sharing. Suppose an outlet, an agent employee gives work to two employees, and he will ask both of the employees to use the same pin in order to transact the money. And after some days, suppose one employee will get terminated from his job, and a new one will join. So in that case, after some days, the old employee might come to the same place and use the same pin in order to transact money using the mobile. So business partner related fraud, it is also similar to the agent driven fraud. Here the employees will defraud the customers. They will also defraud the businesses. So these two are the main categories of fraud threats. In the first category, the customers will completely lose access and control to their accounts. This happens when suppose they have lost the phone. Even then they will completely lose access to their accounts, and even they might get fake calls talking about, like they might ask you about your personal details, date of birth, and pin, everything. Suppose if the customer reveals the pin, then they can reset the pin. Even then the customers will completely lose access to their accounts. And the second main category is the scamming the customer. Here cash in and cash out operations, I will discuss about this later. So when cash in and cash out operations are involved, there is a interaction between the customer and the merchant or the agent. So when there is an interaction between customer and the agent, there is a high risk that the merchant will scam the customer.
What is caching and cache out?
I will tell next time. Yes. So what is the impact of fraud? Because of these frauds, it will seriously dent the credibility of mobile financial service. Telco is a leading mobile service firm. In Africa, they because of the fraud, they lost more money, and even the credibility was seriously dented because of this. And the impact of the fraud is also on the brand, because the organization's product and negative they get seriously impacted by the fraud because of the transactions. The third one is a growth in the number of subscribers. So because for any customer, the mobile service should be trustworthy and it should be secure. So if these two are not taken care of, then there will not be growth in the number of subscribers. And the fourth one is the investment in mobile service by agents. So for a mobile service provider, there will be a lot of agents. So even the agents will fear in investing in the mobile services because of the fraud. So these are the 5 modes of mobile money payment. So here the cash in and cash out operations, only in these two operations, there will be an interaction between the agent and the customer. So here in the cash in, what happens is the agent is, the customer gives money as a cash to the agent, and in turn the same amount is transferred via bank account. So here the process of increasing balance of account by paying in cash to the merchant. So the customer will give in cash to the merchant, and the merchant will send the same money as the electronic cash. In cash out, it is opposite of cash in. Here the customer will withdraw cash from the merchant, and the same amount is sent to the merchant via electronic cash.
I mean, how is that fraud?
What? No, these are not frauds. These are the modes of payment. Okay. And in these modes of payment, the fraud will happen.
Good.
So it's like, suppose I'm an agent, somebody deposits fake money.
Yeah.
I don't know that it's fake.
Yeah.
But I give him the electronic money, so he's gone.
Yeah. Suppose the fraudsters, it will be like initially they will come with real money. So after some time, they will go back that they have urgent work, and after that they will come and give fake money. So initially he might have checked the currency that it is real, but the second time when he comes, he will trust no that I have checked already, so he will just take it like that.
Why do you know so much internal work? I doubt you.
But electronic money can't be fake, right?
No. But if you give fake money to the merchant, he will send the electronic cash, no? So
okay. So basically, you go to the store and tell, I give you 100 rupees.
Yeah.
Can you
transfer
that in Paytm?
Yeah, that is also.
Good.
So the third one is transfer. Here we send the money to another user by using a mobile money platform. Debit, it is same as a cash out. Here we send money from mobile money bank account. Payment is we pay for goods and services to the merchants, which decreases the account balance and increases the account balance in the receiver.
No.
So here we can see in 2018, about 18% of the online transactions were fraudulent, and it increased to 27%. Here we can see 79% of them feel threatened via web payments, and 82% are vulnerable to fraud by transactions, and 66% feel that the point of sale machines are fraudulent, like they are susceptible for fraudulent transactions.
27% is fraudulent, right?
What?
27% online sales.
No, these are the sentiment of the people. 72% feel
left panel. Left panel 27% is fraudulent.
Yeah.
Means 1/4 of your transactions which happen are all fraudulent.
I mean, sales. Total sales happening in online.
Yeah.
27% there is a it's a fraud sales. That's what
Amazon sales and all.
Amazon, like, I'm not claiming Amazon sale.
What do you define fraud as? Right?
Yeah, exactly.
Not money laundering per se, right?
Oh, very basic, shop close, right? There are so many
This is
fraud
something
sales.
that you did.
Shop close is most of the sales I can say fraud. I don't know, I'm not demeaning shop close, but the merchants.
Even Amazon has a tool which like Amazon Web Services, they have a tool to detect the fraud.
Yeah.
Amazon Fraud Detector.
Right.
It is same like the tool is like if you have used MATLAB Neural Networks toolbox, it is just a black box kind of thing. You input the data and you'll get the output. But that is very limited. They have worked for the data of last 20 years only for Amazon's fraud, like the fraud that has happened in the Amazon. So that is very limited, and even the
This is not payment fraud, but it's sales.
yes.
Yeah, you will not get the product. You will get it as a fake
Actually,
product.
total money laundering is a very big subject.
Oh, it's like-
Here only I am dealing with electronic payments. Yeah.
So this fraud will also contain human error, right? Because sometimes
Yeah.
like,
Yeah. Those things are still they remain as a challenge.
And the 27% is it of the total number of transactions or total amount of the money that transact?
Transactions will also include money, no?
No, but different transactions will have different amount, right? Like 100 rupees also a transaction, and
Yeah. Out of those, whichever are fraudulent, that is accounted. Yeah.
No, I mean, the online sales might be the cost, like they're telling me 100 rupees was there, 27 rupees was
if there were 1 crore transactions and the 25 lakh was
That's
fraudulent.
not dependent on the
No.
amount, I guess.
Yeah.
It depends on the number of
Just
transactions.
Number of transactions. And the top merchants affected by frauds are in airlines and jewelry. The second comes is the money transfer through mobiles, online payments.
46% is for jewelry or online.
Yeah, 46% includes airlines and jewelry.
This is online payment or what?
Yeah. The airlines you will book tickets on.
Jewelry. Then.
Okay, jewelry. Maybe that is included in online.
Need to think before buying.
So the emergence of artificial intelligence, to prevent the fraud, here 80% of the fraud specialists believe that technology will help reduce the payments in the fraud. 63.6% financial institutions believe AI will prevent fraud before it happens. And same 80% have seen AI platforms reducing false positives in the payment fraud. So in artificial intelligence, the predictions that we make, we get the false positives and false negatives. False positives is that I am genuine, but even then I am being labeled as a fraudulent. So even though the company won't lose more money in false positives, it will seriously dent the reputation of the person. You might have heard of Panama paper scam. So recently, maybe three years back, the media reported Ratan Tata's name was present in the Panama papers. So
Panama paper is not scam, right? It's just legal way of avoiding taxes. Then suddenly you tell, oh, okay, fine, there are no laws. So that is considered fraud, or is it like?
that is considered fraud, actually.
Okay.
Even now, the investigation is going. In the media report, Ratan Tata's name was named in that. As you all know, Ratan Tata, he has a very good image.
Yeah.
So because of this, the reputation of him will decrease. And after the investigation, they got to know that the name that was mentioned in the Panama paper that contained RATTAN, Ratan Tata. That is a different person than this Ratan Tata. So just because of these false positives, you know how much reputation there is a loss of the people. And so always there should be a trade-off between false positives and false negatives. 72.7 firms are using AI for payment fraud detection.
Fraud specialists are people who are specialized in fraud.
No. They tackle the frauds.
Same with the ethical hacking.
Yeah.
Ethical hackers are the best hackers in the world. Like that.
Okay, this one I will come to it later. So it becomes important in choosing the algorithm that we use in case of identifying fraudulent transactions, because here the data set will be imbalanced, because the number of fraudulent cases will be obviously less than the number of genuine cases. XGBoost has a capability to deal with the imbalance of the data set. Because there we use the parameter scale positive weights, so that parameter will actually take care of the imbalance in the data set. So I have used random forest, gradient boosting, and XGBoost, and I'm just giving an overview of what random forest and gradient boosting is. So the analogy of ensemble methods. The random forest gradient boosting, the base model for random forest and gradient boosting is a decision tree. Here you can see an ensemble of decision trees are fit parallelly. In random forest, each of these decision trees is made to predict a value. Suppose, for an example, each of these decision trees are predicting these values. You can see the error between the predicted output of individual decision tree and the desired output. So when you aggregate all these, you'll be getting 2.91. This is very closer to the desired output. So this is why we use ensemble methods. Here, decision trees are weak learners, because you can see the variance that is there between predicted output and the desired output. We make these weak learners stronger by doing the ensemble or average. So we can see they are stronger together. Here we can compare this total working of random forest with most popular TV show, Who Wants to Be a Billionaire, or Hindi version of it, Kaun Banega Crorepati. Here we can see the lifelines that we get in this TV show is a phone a friend and a poll. Here a phone a friend is compared to decision tree, the individual output of the decision tree, because in phone a friend you will be there will be only one person who will be helping you out for the answer. And in the poll the audience, you will be getting many number of people. So you would have seen the output of the audience poll. It will be a bar graph, and the correct answer will be having the highest peak. So suppose phone a friend. The question that you are asking your friend, maybe your friend doesn't have the knowledge, any knowledge of the question that is being asked. Then what output that he will give? His prediction will be completely random if he doesn't have any knowledge of the question. So the next case is, suppose he has partial knowledge of whatever the question that is being asked. Then the prediction that he gives is somewhat better than random prediction. Okay. But what happens in audience poll? Suppose there are 40 people, and even if 20 people don't know the answer, 20 people know the correct answer. So the correct answers bar graph will be higher. And even the people who don't know the answer, they will give random prediction or partially random predictions. So that will also help out in the final aggregation.
You have like many decision trees to create an ensemble of trees, right?
Yeah.
What is a decision tree?
Okay.
What does this
Desired
2.95
Decision tree is
tells us?
just like,
What does this stat tell us?
okay, fine.
Okay. Decision tree. It has the should I explain from first?
No, just
Okay, so decision tree, it based on set of rules from the root node till the leaf node, the input is passed on, and based on the set of rules, you will get the output.
what is the output?
Suppose it might be a regression problem or classification problem. If it is a regression problem, you will be getting a numerical output, or if it is a classification problem, you will get the classes 1 or 0.
Can you give an example?
Yeah, suppose see, for a regression problem, the final output will be the average of all the outputs of the decision tree. So for a classification problem, it will be the mode. That means, suppose there are 40 examples, and out of 40 samples, 30 of the, suppose there are 40 trees, and out of 40 trees, around 30 trees are predicting one class, and 10 trees are predicting another class. So you'll be getting the majority voting.
Keeping it ratio.
Yeah. So this can also be compared like suppose I am suffering from a disease. I will go to a doctor. He says that you should get operated for this. So I suspect him, and I will consult four doctors, and based on the majority voting, I will decide whether I should get operated.
That's good, really.
And do we also check like suppose one of the trees is sort of dependent. Suppose like in the
Yeah, even that is an issue. I will come to that. So when you take these individual decision trees, so individual decision trees are prone to overfitting. Here you can compare that to that image. So overfitting, when it happens, each and every point is fitted so precisely. So if you even change the input a bit, then the result will completely change. So there we can see even the small disturbance will completely destroy the rock pieces. So it can be compared to the physical balance. So in deep learning, you know dropouts. That is a regularization technique. So we reduce the overfitting by using dropouts. What we do, we introduce error. So we want the model to make some error so that it will generalize for everything. So it is like suppose in a class there are two smart students, and for every question that the teacher is asking them, only those two smart students are answering. So in the middle, suppose the principal comes to the class and he'll randomly pick some student and he will ask some questions, and they will not be able to answer. So what we do, we will the teacher will ask those smart students to shut up for some time, and she will ask other students to participate in the answering the questions. So what will happen here? Since the teacher is restricting those two smart students, that is the dropout. We are restricting them from, and the remaining students, when they participate, obviously they will make errors because they are not smart enough than these two. So when they make errors, the teacher will correct the errors. That is the learning that is happening. The weight updates happen only when teacher teaches, and also the class will be able to generalize. Like whomever you pick and ask the question, they will be able to at least say some answer. That is
you are giving, man.
what.
Today you have prepared a lot, I guess. You're giving a lot of.
No, this is part of my MTech presentation, so I'm telling everything.
You are using MTech presentation?
Yeah, these slides are from MTech presentation.
One question.
Yeah.
So in deep learning, suppose we have a network. The way I learned that we do dropouts is we randomly block off three of the nodes, and we just send the zero this thing to the next layer. So how
We are forcing others to answer. That is it.
Yeah, but how is it implemented in a decision tree? Like
No.
Dropouts.
No, I'm just comparing it with overfitting. That's all. Okay. I just gave you the example. What is overfitting? How do you rectify in deep learning? In random forest, we actually see the decision trees. If you only fit a decision tree, then the depth of the tree will be infinite. So we will actually trim the tree by using the hyperparameters such as maximum depth, minimum number of samples.
Pruning.
Yeah, pruning. So what is the need of ensemble methods? So here the base models are the decision trees. So when the base models have a low bias and high variance, then we want to reduce the variance. So we will be using random forest. So if the base model is showing high bias, we need to reduce the bias, and we will be using sequential models such as gradient boosting. Here we need to maintain the bias and variance trade-off. So this side it will be underfitting, this side it will be overfitting. You need to maintain the balance. We'll combine all the decision trees together in order to create a strong learner that achieves better performance.
No, why I'm asking, why not use deep learning?
We can use.
So we can benchmark and see it outperforms.
Yes.
See, the stuff about deep learning is like it is a black box approach.
Yeah. Correct.
Most of the companies you see, they use advanced ML as compared to deep learning because you can explain the algorithm. You can say what exactly is doing, and for every specific input, you know
totally fails. I mean, there is a trade-off. Like, let us the percentage is very low. The accuracy percentage is like some 60, 70, and your cruciality of the accuracy is like 90%. That time you go for deep learning.
Moreover, the approach it will be decided based on the data set also. This is highly imbalanced data set. So even smart undersampling, oversampling is not required if we use XGBoost. Yeah, so we'll not use deep learning. So random forest. I see here the trees. There are two types: shallow trees and deep trees. So if the tree is shallow, then the choice is for a sequential model, that is gradient boosting. If the tree is deep, then we'll choose bagging method, that is random forest. So random forest it combines both bootstrap sampling as well as random feature subspace selection. So I will explain what bootstrap sampling is. So here this is also important because while fitting each tree, we are not considering each and every feature. We are only taking a subset of features.
So what do you mean by subset of features? You're going to put an algorithm there. It's like again ensembling.
Like while fitting a decision tree, each node is splitted based on the bootstrap samples and the number of features. So suppose I have 10 features in my input data. So to split each node, I will not be using all the 10 features to split.
Okay, so you're using ensembling for feature-based kind of.
No. Ensembling is different. This is a technique used only in random forest.
Okay, you're sampling it based on the feature.
Yes.
I forgot what is bootstrap sampling.
Yeah, I will explain. Yeah. So bootstrap sampling, it is a statistical technique. Here, suppose we have a data set of size n. We will be generating a number of small subsets of data. See, there generates samples of size b from a data set of size n. Here, b is less than n. So the bootstrap samples, they are almost representative and almost independent. So they can be said as almost IID samples, independent and identically distributed. Here, what is representativity and independence? Here, representativity means the data set should be large enough so that it will be able to capture most of the complexity in the underlying distribution, so that each bootstrap sample that we generate would be a good approximation of the sampling from the real distribution. And independence, so each of the bootstrap sample that we generate should be independent from each other. There should not be any correlation between the bootstrap samples that we generate.
So, I mean, what algorithm do you use to select the samples?
Actually, this is inbuilt. It is done
Inbuilt,
in inbuilt. It is
Random sampling.
yeah.
Random sampling.
Random
Random sampling.
So this is similar to batch processing, right?
Conditions.
Not exactly.
I mean, the B is the batch of. B is the number of features or number of records, number of data samples.
Data set. A subset of the total data set.
Total records is 100 means some 10 records is.
Yeah.
Similar to many batches or batches.
But here a correlation should not be there. It should satisfy both conditions.
Correct.
Here independence and representativity should be taken care of.
What does that mean?
Suppose see you have 100 samples and you are creating a bootstrap sample which is a subset of these 100 samples.
Correct.
Okay. So the sample should be such that each of the samples you generate.
Similar samples.
Yeah. Because if there is a correlation between the bootstrap samples, then even the decision tree that you fit will be correlated.
Correct.
Okay.
So you won't allow the same sample to be fit again.
Yeah, not completely. So that's why I'm mentioning here almost, not completely.
So how do you do representativity? I mean, correlation can make sure that it's different. How do you capture that it is more complex?
See, the data set should be so big enough that each bootstrap sample that you generate is replicating whatever the whole data set is.
This is basically this condition will be satisfied if you have a big data.
Yes. Otherwise this condition will not be satisfied. Even though if this is satisfied, this is not satisfied.
Okay, so you should not use bootstrap sampling at that time.
Then there is of no use. Overfitting will happen anyways.
Not be able to satisfy this.
So bootstrap sampling, it just sees the correlation, but you have to see the representation.
Yeah.
So this is to reduce the bias in the model. If it's too similar model, it will become overfitted and the bias will be
Similar to the original data set actually.
Yeah.
That's it. So it will be large enough so that you select only 2 out of 100. It will not the end will be first condition not satisfied.
So your data set sample should be large enough to represent your original data set. Suppose you have like 100. Suppose you have like 100 transactions, out of which 10 are fraudulent. So you want to select like sample of 10. So you can take like maybe one fraudulent and if it's completely random, then it is representation of the original data set.
So this just describes.
This is already taken care by test data split by stratified.
That is random.
No, that is cross validation you're talking.
No, stratified.
Stratified.
Parameter is stratified. You're right actually. If you use stratifying, it takes care of that. Each class is represented in the same proportion as that.
No, that takes care only of the Y labels, right? It makes sure the
Both
classes are in same balance when you
same proportion actually. Right?
but they take care of the features what I guess.
No, this one takes care of sampling. So before you even put it to the test, and so I think that one, the test and train, the split will be.
Yeah, both are different.
Yeah. I mean, they're very related, but it's a little bit different.
So here, actually, here the average. Once we average the outputs at the end of the decision tree in random forest, we are not actually changing the expected answer, but we are in turn preserving the expected answer and trying to reduce the variance of it. That means, suppose the output is following some normal distribution, we are not actually changing the values of the distribution, but we are actually trying to reduce the variance of the distribution.
So how do you reduce variance of a
by fitting many trees?
Normal distribution.
No, I just said for an example. Suppose the output is following a particular distribution and it has a high variance. Each decision tree will be showing a high variance with respect to the desired output. So we are reducing the variance by fitting more trees and aggregating it.
So bagging is increasing the trees. Or decreasing
No, that.
Bagging is
No, what is bagging?
decreasing the trees.
See here, bagging is just the two things that I showed: random feature subspace selection and bootstrap sampling. These two, when you combine these two together, it is said as bagging. And moreover, in bagging, the main difference in random forest and gradient boosting is in random forest we fit the decision trees parallelly. Okay, in gradient boosting we do it sequentially. So each tree at a particular instant will be a better version of the previous tree. So here. We can see the training data set is there and number of bootstrap samples are generated. Here in-bag samples and out-bag samples. Each bootstrap sample when you generate it and before you send it to build a decision tree, out of bootstrap sample 66% is taken as in-bag and 33% is taken as out of bag. So what does this mean? Out of bag is the samples that is used to validate the decision tree. And this 66% is used to fit the decision. Okay.
Is the proportion fixed or is the hyperparameter I can tweak it?
No, you can't tweak. I will show.
It's like crossfold only. 2 parts and 1 part is given.
No, but this is random.
Suppose the probability
of you divide sequentially into 5 parts or 10 parts. But here it still is random. At every
66% is random samples taking out of what?
That's random. So there is a slight difference.
Okay. Suppose I have 5,000 samples, and what is the probability of selecting a particular sample out of 5,000 samples? 1 by 5,000. So probability of selecting a sample is 1 by 5,000. If I take it as in, this is 1 by. So what is the probability of not selecting this particular sample out of while fitting the bootstrap? 1 minus 1 by. 1 minus 1 by. Suppose after n samples, what is the probability of not selecting that particular sample?
N sample.
Yeah, after n samples. Suppose a bootstrap sample is there. Okay. Suppose you are feeding a bootstrap sample, and what is the probability that a particular sample is not selected after n draws?
Are you putting on that?
Bootstrap means you are putting it back. See, bootstrap means sampling with the replacement. Yeah.
Oh, is it?
You are talking about mutually exclusive.
This is with replacement or without replacement?
This is with replacement.
With replacement.
Yeah, bootstrap is with replacement.
No, both are there. With replacement, without replacement, both are there.
Without replacement, how do you say it's bootstrap?
See, in scikit-learn, as far as I know, bootstrap sample is true and bootstrap sample is false. Both can be specified. Actually, you are correct. When we specify it as false, it is not a bootstrap sample.
Yeah.
Otherwise, those conditions will not be satisfied. So when this n tends to infinity, we will solve this. Let
Integral of omega x is minus omega.
so this will be okay. So when n tends to infinity, y tends to 0. So limit y tends to 0.
There is no probability.
What?
Why is the probability? Right?
Yeah. No. The probability of selecting the sample.
Yeah.
So this one is
Okay.
this one. No. You can say is power of n into n can be written as power n whole power. So 1 plus y minus so if I use only this 1 by I can solve for limits by applying log. Suppose this is x.
Okay, you are beginning to lose us now.
It's like 1 by 1 plus root of y.
Equal to y so suppose this is log base. So this is a 0 by 0 form because when you substitute 0 log 1 is 0, 1 by 0, this is 0 by 0 form. When you get to 0 by 0 form, you can differentiate numerator and the denominator separately. Yeah, the next one is a boosting method. Slides are not. Yeah, it is. So the next one is boosting method. So here we fit the decision tree sequentially, and they are independent. Training of model at any step depends on the models fitted at the previous steps. So the base models, as I explained before, they show low variance and high bias. Shallow decision trees with only a few depths. These gradient boosting trees, they are shallow trees. That's why there will be few depths. This is less computationally expensive. This can also deal both regression and classification problems. Yeah. So in gradient boosting, we fit the decision trees and we allow it to make predictions. So once the predictions are made, we can calculate the errors, which are the residuals. So we fit the next tree based on the errors that we have got from the previous tree. So in the second step, we will be combining the new tree with the tree from the previous iteration.
Can you increase the font slightly? Control plus. Yeah.
Enough?
Yeah.
Okay. So the data set that I have used here, it is a synthetic data set. Here in this data set, I have 65 lakh samples. So out of these 65 lakh samples, initially we can see.
When you say synthetic data set, what does it mean?
The real transactions, there are they are only suppose 5 lakh to 10 lakh samples, only those samples are there, and they have generated synthetically from that. So these are the features.
Basically, it is like augmentation data.
Yeah. Yeah, he can see. Okay, these are the features that are present in the dataset. Step, type, amount. So the type includes 5 modes of payment that I showed in the presentation. Name, amount is the amount that is being transacted in each of the step. Name, origin is originator's ID, and old balance at the origin, new balance at the origin. Name, destination is the person to whom the money is being sent. So old balance destination and new balance destination. Yeah, step is an hour, 1 hour. This data is for 1 month. So each step is a particular half hour of a day. So totally there are around 700 steps.
Sorry, this is for 1 month.
Yeah, 1 month. So here we can see the destination's ID, old balance destination, new balance destination, and it is being classified whether it is fraud. Each flagged fraud is suppose the amount transacted in each step, it is more than 2 lakhs, then it is labeled as is flagged fraud. But this is inconsistent in this data set. Out of 65 lakh samples, only 16 samples are being labeled as is flagged fraud. But there are many transactions where it is exceeding 2 lakhs and is not being labeled as flagged.
Manually, somebody has done that.
Yeah.
Then also it's possibility the 2 lakh transaction, only 16 are fraudulent.
No, 65 lakh transactions, only 16 they have labeled is flagged fraud.
Right.
Is flagged fraud, what they have described is if the transactions amount is more than 2 lakhs, then it can be labeled as is flagged fraud, but it is not consistent here.
No, but that is highly unbalanced data set.
Yes. Here we are actually not using is flagged fraud, we are only using is fraud.
Oh, I see.
Even that is imbalance. So out of 65 lakh samples, is fraud is only for 8,000 samples. Okay.
But still it's highly
Yeah.
You have to balance it.
Yes. So there are 5 modes of payment, as I said before. So out of these 5 modes of payment, only 2 modes of payment have all the fraudulent transactions. Okay, that is cash out and transfer. So cash out and transfer, only these two if I consider, then the whole data set will come down to 27 lakhs.
Out of that 8,000.
Yeah, out of that 8,000. Yeah, here we can see the value comes.
So this is some payment portal. This is a real data set?
Yeah, this is a real data set. On that only they have generated synthetic samples.
So how many is flag fraud is fraud?
No, all is flag fraud is fraud because only 16 are there.
Okay, okay.
But did you do analysis on 27 lakhs or 65 lakhs?
27.
27 lakhs, that's right.
No, is it like out of 8,213 fraud cases, only 16 are flagged fraud?
Yeah, you can say that like that.
I mean,
that means 8,000 around 8,200 frauds are not detected.
Yeah,
that's what you mean.
No. See, flag is done when the transaction amount is exceeding 2 lakhs. That's all. Yeah. There is nothing related to each fraud.
but how did the rule fail? Rules
No.
should work, right?
Yeah, that's what. In Kaggle, they have just mentioned it. If it is about 2 lakh, then it should be flagged fraud, and it is not matching here.
No, I think they'll anyways do the fraud detection on that.
So this is a Kaggle.
Because usually in rule-based systems, we actually give a threshold. So the same thing they are reflecting here.
See, recently there is some debate on Kaggle. The problem with Kaggle is it is highly canned everything. So it doesn't give real world.
But Kaggle generally they will validate the data set before uploading. Much more checks and balances are there in Kaggle.
But it's very canned data set you get. When you go to real production, it's totally chaos.
If you compare any data set, compare any
both
data
types of data sets are there. You get like you can upload your own data set also.
Some purists
No, but before they make public, they'll validate that.
Then
So much more checks and balances are there in Kaggle.
The best way to do it is
somewhat clean data sets.
Yeah, somewhat clean data.
That is the problem because in production you don't get.
the best way to do it is use the competition data sets, like from previous competitions and stuff. If you use those data sets, they're really good.
Yeah.
So next is the minimum amount flagged as fraud is 3,53,000, and the maximum amount is this is around 1 crore, I think. Yeah.
Minimum amount flagged as fraud.
That's right.
But in that you had already shown 181 is flagged as fraud, right?
181.
Yeah.
16 as well.
16. What happened?
No. Oh, is flagged fraud case you are talking?
Yeah. Connection has been lost.
Connect to rework.
Yeah, restore. Okay.
Rendering.
It is very slow. Okay. Again.
Again the password change.
Yeah.
Just bouncing.
Yeah, they are changing the bounce.
Okay. These are the number of transactions based on the type. The graph. The next is. Okay, so here there are two persons. The one is a customer and the next one is a merchant. So in the origin and destination accounts ID, we can if the name is starting from C, then it is a customer, and if the name is starting from M, then it is a merchant. Here the number of records based on the customer and merchant transactions at origin and destination accounts are given. There are you can see those many number of customer to customer transactions and those many number of customer to merchant transactions. but the rest, the third one and fourth one are zero. Only first and second are there.
So all customer is the one who is transacting.
Yes.
Either to customer directly or to merchant.
Yeah. Because in debit payment and transfer online payments and all, both sides it will be customer only. Yeah.
Or customer to customer is like I'm transferring it to you.
Yeah, that's what I said.
You're also a customer.
Yeah.
I'm also a customer.
Yeah, that's what I said. Yeah. So here you can see all the fraudulent transactions, 8,000. All of them are between customer to customer only.
So you say that merchants are very good.
This is a biased one. Yeah.
In the data set, for each customer, you have provided unique ID.
Yes.
How many accounts, bank accounts recorded? Suppose there is a limit of 2 lakhs, right? What is the benchmark of you can flag a person that he's a fraud of?
No, that is just for that. He is flagged fraud. Only for that threshold is there. 2 lakhs.
2 lakhs.
Yeah.
Suppose a person have more than 10 to 15 accounts, and he's doing on.
That's what we see. Those records we are seeing it, whether the multiple accounts are there for a particular customer or not. Those things we are seeing it here. Yeah, here you can see number of records where the destination account in a transfer is same as the originator account in the cash out. So what the fraudsters do is they'll first transfer the money, and after that they do the cash out. What the cash out is, once they transfer the money, they will go to the merchant and they will immediately transact that money. So that is fraud. So totally, but only 3 samples are showing like this.
How do you determine as fraud? What if I want the money to be in bank?
See, so suppose I'm sending money to you. Okay, I'm sending the money is deducted from my account, but it is not credited to your account. In between, the fraudsters have taken my money, and immediately they are cashing out with the merchant. Okay. So this will happen. So I am checking whether the destination account in the transfer is same as the originator account in the cash out. But only 3 of the transactions were similar like this.
Out of 27 lakhs.
Yeah.
Smart.
Yeah, as I said before, I am taking only the cash out and transfer transactions for this data set.
So there are type as null also.
Where? No?
Yeah, null is there.
Where is it?
Type cash in, cash out.
Yeah.
And
in cash out, 0, 1 is genuine and fraudulent.
Yeah, I got it.
Yeah.
So one is type as null.
No.
But
cash out only. In cash out, you have fraud.
Cash out
yeah. Group by.
Okay. I thought it is value concept.
So here I am taking only the transactions for transfer and cash out. So totally I have 22 lakh data set for cash out and 5 lakh for transfer. Totally 27 lakh. Yeah. So here we can see if the at origin there is a deduction in the money, but it is not reaching to the destination. So when the amount transacted is not equal to 0, that means if we are sending some amount, but it is not getting reflected to the destination accounts. So this is happening for almost 50% of the samples in the 27 lakh data set. But we can't say all these are fraudulent. That is important.
Okay, transaction failed. Sorry for the.
So here I am imputing, treating all these zeros as missing values. I am imputing as -1. Suppose destination and destination accounts, old balance and new balance is 0 and amount is not equal to 0. So for old balance destination and new balance destination, I am imputing as -1 instead of 0. Yeah, I have generated a strip plot. So blue represents transfer and orange represents cash out. So here we can't see any kind of pattern as such.
Orange represents this one.
Yeah, cash out. Yeah.
So in this we can say cash out amount which is done cash out is pretty less as compared to transfers. Yeah.
Okay, I didn't explain nothing.
Doesn't have much, that much
Carry like 1 crore.
Feature engineering. Yeah, I have created 2 new features which accounts for the error that is between. So here we can see whenever the transaction is happening, the new balance plus amount minus old balance should be equal to 0. Okay, so if it is not 0, then everything will be accounted as a new feature. So error balance at origin and error balance at destination. Here we can see opposite polarity.
What do you mean by opposite polarity?
There is a pattern here that can be observed. Here, this is a plot between error balance, fraudulent and genuine transactions.
Okay.
Here there is a clear separation. So from this, what we can infer is the new features that I have imputed, they are able to find out some of the patterns.
So a lot of errors is happening on transfers as compared to
yes.
in fraudulent.
Yes. Because most of 22 lakh samples are there in which one, cash out, and only 5 lakh are there in transfers. So this one is error balance at origin. That was error balance at destination. This is for origin.
Origin is not that. So origin means that is a mistake from bank side. Amount is detected, but the balance is not reflected in the right way.
Yeah.
Can be customer to customer transactions also. It's just the origin account and the destination account. It need not be.
Yeah, only bank we can't say like a generalized statement we can't.
Yeah, the origin account can be the merchant also, or it can be another customer also. Suppose I'm transferring to someone else. The origin account is my account and the destination account is the other account. So if there is a mistake in my account itself, it will show up in the second one.
Okay, similar kind of plot I have plotted against the step. Step is the har. So totally there are 700 steps, and this is error balance at the destination. The red and green represent red is fraudulent and green is genuine.
So all these things can be solved with blockchain if suppose you get blockchain.
I don't have any idea.
Yeah, I mean, you don't need to have this only blockchain.
One of the solutions.
Imagine that
One of the solutions.
One of the solutions will be blockchain.
Okay, the similar plot for origin accounts. That was for destination. This was for origin. So for all 700 steps, we can see all fraudulent transactions are at 0. So when a 3D plot is made, we can see a clear distinction here.
Okay.
So
we caught you.
You've done nice visualization.
This is step error balance destination, and the z-axis is error balance at origin.
Without the log,
this is SNS
becoming too.
Yeah. C1.
Yeah, matplotlib, right?
Both are integrated.
C1 is based on matplotlib.
Yeah.
That's a better visualization.
Yeah, just practical.
So here
On matplotlib.
Back in this
Can we do that?
It does coloring on that.
So what it puts there is SNS.
You can access the basic method like arguments also from C1. Yeah.
Okay.
You can send arguments. So, one question, why did you take log just to,
Yeah, just to scale it down. So here we can see when we can if we plot a three-dimensional plot, then we can see the distinction, because in the previous 2D plots you did not see this distinction. So at least it was observed in error balance at origin. Here here at least you would have observed. But when you take account of even the destination accounts error, then you will get a 3D plot. Here you can still see at the bottom some red points are there, but most of them are at the top. Yeah, when the correlation matrix was plotted, here.
This is part of your MTech project. Huh?
No. Only those slides were.
This is pretty extensive. You just developed it.
Yeah, this one. So here the error balance at origin is showing more correlation. Here we can see 98% correlation.
Yeah.
So that will help out. Yeah. So that will help us out in finding the patterns. Yeah.
So did you treat that actually after the correlation is found? What is the action taken?
No, those are the features that I'm using. Those two features I have created by feature engineering: error balance at destination and error balance at.
Imputed the bias in your model, na? Yeah. Because the correlation is so high. It's taking time.
What about multiple?
This much time it will not take. Yeah. With amount.
See, the amount it is.
Because it is calculated with the amount, na? Error.
But your new balance destination is not.
Yeah, new balance destination is showing 0.5 correlation. This is showing 0.98.
That is true, because the new balance and old balance are highly correlated because they are
related to amount.
Imputed bias in the model.
So you have to remove those features.
Yeah, remove that
to
feature
get better accuracy from.
Correct.
No, two features which are tracking each other. One of them should be used. Both should not be used.
Yeah.
Right?
Okay.
It will create a multi-collinearity.
So either of them I should be using.
Yes.
Yeah, same thing in this new
Because they
balance.
represent
New balance destination and all balance destination also you have to.
And again, one of them we should see in the new balance version also. If you notice over there, there also new balance and old balance is highly correlated because it is because of the amount.
Correct.
Yes.
It is like X plus and X minus.
Logical also. So we should actually remove new balance or old balance, one of them.
Okay.
You use only one of them, and error balance origin also you should remove.
Then you will not have features. Like 3 or 4 features finally.
No. Only 2 of them, na?
I mean, that's what PCA will also do.
Highly correlated.
Reduction.
Up to for 100 to 10.
Yeah.
Okay, it's different.
PCA is totally different.
Here we have only 8 features.
Yeah, this will create something called multi-collinearity.
Multi-collinearity.
And you have included the Y label list fraud also in this correlation.
Is fraud. Oh, it is also there. Okay.
but there are like a few transactions where the old balance is not equal to the new balance. That's why fraud is sometimes. So that's why it's not exactly one.
That's fine actually.
So if you take both the features as one,
anything above 0.85, we take it as highly correlated and remove that actually.
So that,
but if you remove, then you won't be able to figure out the.
No, he's taking the error out of it. Right? What is the old balance minus new balance? What is the error out of it? That will become a feature.
Oh yeah.
So instead of taking these 2 alone features, merge them into one single feature.
Correct. This thing and take the error.
Yeah, exactly.
Okay. So in the input features, since this is a highly imbalanced data set, even in the input features there is a skewness. So for amount, when I plotted this graph, the skewness was 40, So when I did a square root transformation, it got reduced to 4.3. Next cube root 2.05. Box Cox transformation, it reduced to 0.08. So the skewness for a normal distribution, it is 0. So the box Cox, when you do the transformation, it will actually convert your input feature similar to the normal distribution.
Yes, I didn't understand this one actually. What is skewness? Here, what is skewness?
No, skewness is just the distribution of the input features.
I see.
Here, the amount I'm using as a input feature and distribution.
Okay. Yeah, they see the kurtosis is very high.
Yeah. Skewness, kurtosis, both they come in hand on hand. So initially I implemented like after doing data transformation, I did the training and testing, and without data transformation also I was getting the same result.
What is box Cox?
That is also a kind of transformation. See here, square root, cube root are transformations similar to that.
Up your code.
Yeah.
What is the equation there?
This is a ready-made API. Okay, from my sake only. What is the objective of doing this actually? How does it help?
See, because the distribution, if it is normal distribution, then suppose while dividing the trees, bootstrap samples, it is not fitted on the complete data set. Only a part of the data set is used. So if it is highly skewed, some of the extreme points will not be there in a bootstrap samples. So always we tend to make the distribution as normal as possible.
So this is a technique to use is more normalized actually.
Yes. Transformations. But yeah, it is also important where we do this kind of transformations, because once you transform, you are actually cutting down the extreme values. But if for a particular case those are the important things, then you lose out the information.
So did you check which are the rows it has removed actually, whether they are relevant or not relevant?
Means?
It will have removed some rows from there actually, from the original data set.
No. I haven't.
It's not removing. It's just
transforming.
Transforming.
The amount of values
Okay,
is
that's
transforming.
fine.
Yeah, here splitting of the data set into 70-30. Initially I used logistic regression. Here I got, here the recall score is the metric because it is highly imbalanced. So in logistic regression I got 43% recall score, and that is a confusion matrix you can see. Lot of true positives, false positives and false negatives.
How does false positives affect recall score?
No, false positives is a precision. False negatives is recall. So when you want to maintain both the trade-off between false positive and false negative, then you have to take care of both of things, which is AUC, area under the curve.
Area under which curve?
Area under the curve, that is okay.
You're testing him again and again.
Area under which curve?
You know the answer, but you
just asking. Yeah, I will tell that.
Suppose probability of classifying a sample is equal to 0.6. Okay. Probability of classifying a sample as positive if it is 0.6. So probability of classifying if the negative of this is 1 minus 0.6 is 0.4. Okay. So if you plot that distribution, suppose this is 0.6, this is 0.4. Suppose it is following a normal distribution with the mean 0.6 and standard deviation 0.1. I will get a plot like this. Similarly for this also.
What is an ROC curve?
I'm coming.
You got an AI instructor in the audience.
You're like that strict teacher in the class. We used to have, right? What is that?
That example.
Who's the teacher?
He's the teacher.
So ROC AUC curve, this AUC score, it is the ratio of true positive rate divided by false positive rate. Okay, this one anyways I will show in the presentation. So random forest, yeah, random forest it improved and the recall score is 67%.
99%.
Accuracy. Accuracy it will be the same.
Hey, that counts as highly overfitted, no?
Which one?
That accuracy.
See,
99.9% is highly overfitted.
see, there are how many positive samples, how many negative samples.
Imbalanced data set.
Yeah, imbalanced data set. Obviously.
Yeah.
See, that is with the problem with XGBoost and random forest. They overfit, right?
No.
Accuracy
Accuracy. See, the accuracy we should not see the metric for imbalanced data set. We should either see precision or recall. In this case, recall.
No, there is no fraudulent for all the transactions. Point is, if we say there is no fraudulent, accuracy will be 99.9%.
Exactly.
That's what there is 99. See the
No, are you
number.
saying it's not overfitted? I didn't get it. 99% is overfitted.
The different, there is a difference, right? See, I have only out of 1,000 data transactions, I have only 9 fraudulent transactions.
Okay.
Okay, I have only 9 fraudulent transactions, and my model which says there is no fraudulent transaction, which is a dumb model, is 99.1%, 9%, 1% accurate.
Correct.
If you tell everything is not fraud, then it will be 99.
Yeah.
My dumb,
Out of 100 samples,
model,
if there are 90 positive, 10 negative, then it is 90% accurate. Even if it is not detecting.
So we'll use a recall score.
Yeah.
So you are saying accuracy is not a good measure of overfitting.
No, accuracy is not
Depends on the data
good
set.
measure when the data set is skewed.
Yeah. Depends on the data set. So random forest, this is the case. Yeah.
Yes, right.
Which always the higher value of the diagonal, then that's good.
Which always confuses.
That's why it is a confusion.
So this is the result for gradient boosting.
Okay.
That's just a comment by Sid.
Okay. So the classification report here, we can see recall is 0.95, F1 score 0.96.
This is decent. 0.95.
XGBoost.
No, gradient boosting.
Okay.
The next is
Which gradient boosting you have taken?
light.
LGB.
So this is a ROC curve for all the 3: logistic, random forest, and gradient boosting.
I mean, which is our logistic is playing well.
Yeah, here we can see the scores.
Always, I guess. Logistic always plays well.
Difference between LGB and XGBoost is what different. Slightly different.
So when XGBoost was plotted,
XGBoost is much faster.
Okay. Extreme gradient boosting.
yeah,
Oh, you use that this time.
So XGBoost will also account for imbalance in the dataset. Here we can see the weights. So this scale positive weights will account for those things. This is a formula square root of number of samples with 0 and the number of samples with 1. So this weighting will be used in order to split the decision nodes.
So we are giving the percentage of the label values. How much percentage of?
Yes. If positive samples are less, then it will take account of it. The weights will be less.
So for XGBoost, you can directly give an imbalance data.
Yeah.
Oh. Okay.
So the AUC score for XGBoost is that much, 0.9999.
What is the recall score?
Recall score for XGBoost is not done here. Only the area is plotted.
You can minimize your screen to show that diagram.
Yeah.
Or you can just left click and open the
Control minus. Yeah, it will come in the range. minimize further.
But just left click and open image.
Yeah, open image in a new tab.
Where is it?
It's not coming on your application. You can just minimize.
Okay, what is it? This is a tree, XGBoost tree. This is a XGBoost tree. Here we can see the splitting that is happening till the leaf node.
So this one you can't do that in this one.
Exactly this.
If merchant is asking like, how are you saying that it's predicting is fraud? We will have no clue. We can't say that our this node is activated at this time.
Only ML models are interpretable.
But exactly that word is.
But the point here is predicting a fraud as fraud is more important than finding out how it is becoming a fraud.
No, not always. Not always.
If they trust you, they're like, okay, fine.
Unless until you are
do, one time you're wrong, yeah.
No.
90%.
See, even true positives, no, false positives and false negatives, you can check how it is classifying it.
Unless until you are part of Google, Microsoft, IBM or something, these all will never work out. If you go to any other companies who are working, they will do more of like advanced ML because the model is highly interpretable and you can clearly tell you can say that for this specific input, you will get it. So that's what I am working on, right? So I can say you that so clearly because AI is not everyone is a technical person and it is very hard to make a non-AI person understand the AI model.
The result, deep learning gives better results, right? Like if you can't explain what
it is unstructured data.
Like at the end of the day, deep learning is better.
No.
So no, not always. Not always.
Suppose you know how that neural network puts this data.
You know what I'm saying is that maybe in other cases, yes, fine. But when you have a 1 crore rupees fraudulent transaction which is unnoticed, okay, it is better to notice that than finding out how that is going to be fraud.
So this explainable AI is a very big topic.
Machine learning is the best.
No, explainable AI is a very huge topic. I think we can rest that. We can debate. There's a huge debate about explainability of AI, so it's a broader topic. So
definitely for unstructured data like images, text and all, we can use deep learning.
No, we can use it for everything, but you should know how the neural network, which neuron is activated.
Every time
you can visualize that neuron.
Necessary that your deep learning model will give you a better accuracy or record.
No, I'm telling.
Then
as a black box, it might not give, but if you know what is happening inside, it can visualize it.
If you see this in Google decision scientist, she herself uses ML mode. 99% ML mode as compared to DL.
See, Google they use everything. They have one person to do this, they have one person to do that.
no, I think we can rest this topic. You can
Continue, please.
Sure.
Okay. Without considering the XGBoost, if I just compare these three, see here we can see number of false negatives and false positives, both are more, and the amount of transactions that is accounted for in FN and FP, you can see 0.6 billion. Here it is 0.22 billion.
Okay.
And true positives is the amount that you are saving by predicting it as a fraud. So random forest, it showed a better result than logistics. See 0.24 and 3.39. This much you are saving. So false negatives, this much you are losing. But in gradient boosting, here you can see here this is it should be still less than this one, but it is more. Even though the false negatives here is 872 and here it is 126, there are very less number of false negatives. Here you can see how much amount this is accounting for. 0.75 billion. This is accounting for 0.24 billion. And true positives also, the amount you are saving is 2.88 here. Here it is 3.39. Here the number of counts is 1672. Here it is 2370.
And again, random forest is the best.
That's no, you can't just say that like that. See, here the recall score is 67%. Here the recall score is 95%. But just by comparing the amount that you are saving, it is the reverse.
Yeah, correct.
So you can't just say, see, this might happen here. Okay.
No, it's taking the amount feature as a higher priority in a random forest.
Yeah, you can say
weightage for the amount. If let us say if it is a higher amount, then it's giving higher weightage of fraud as compared to a lower amount in a random forest.
Yes. See, moreover, in random forest, each tree is independent. Okay.
Yeah.
So there is a probability that you are detecting more over here than compared to gradient boosting, because this is an update of each and every previous model. So suppose it all depends on the errors that a particular decision tree generates, because the next tree is fitting on the errors of the previous tree. So
Speed-wise, gradient boosting would be higher.
So that's all.
Cool.
Good.
You're saving 3.4 billion. What is your quota?
So done.
Okay, thank you. I am ending the presentation.